Firefighter and a fire. A firefighter, and here's the firefighter down here, is trying to shoot water straight right there into the middle of a house window located at a height 6 meters above the ground. The distance between the firefighter and the house is 8 meters. Okay, so there's the 8 meters, here's the 6 meters. And she holds the fire hose 1.80 meters above the ground. That number is right there. The water leaves the hose with a constant speed of 12.5 meters per second. Initially, the firefighter aims the hose at 61 degrees above the horizontal, but misses the window, which is no good. How much time did it take for that water flow to reach the house? How far above the middle of the window does the water go? What is the magnitude and angle of the velocity of the water when it strikes the house? And then, what must the minimum angle and speed of the flow in order to get water into the middle of the window? And this is one of the beauties of math and physics. We take all those words from the previous page and boil them down to this. This totally summarizes what our initial conditions are, and then we can look at all our further statements here asking us what they want us to find. So the first thing you do, two-dimensional kinematics, resolve your initial velocity into its x and y components, and we'll be using this over and over again. To find out how much time it took for the water to get the house, to hit the house, we have our second kinematics equation, no acceleration in the x direction, and in this case the house is 8 meters away. We're going to call where the firefighter, she's at 0 meters, so that's this number here. Here's the velocity of the water in the x direction, and find that it takes 1.32 seconds for the water to get to the house. It's a pretty slow flow of water out of the hose. We now want to find how far above the middle of the window. So if the middle of the window is like this, and the water hits up here, we want to find this distance here. So we're going to find the height of the water stream at t equals 1.32 seconds, which we found in part A, that's when the water hits the house. And we're going to use the second kinematics equation in y. Then we'll subtract the height of the middle of the window, right, to see how high, let's see, to find this number here, right, because this equation that we're solving will give us this height, but we want to find out how far above the middle of the window we were. So we plug in. This is going to give us our height where it hits. Here's our initial height. Make sure you put the 1.8 meters because the fire hose is above the ground. We have the initial velocity in the y direction. Here's the time it took before it hit the house. Here's the effect due to gravity. And we find that the water hits the house at 7.65 meters above the ground. But once again, we had to find out how high above the middle of the window. So we have to subtract 6, and we find we missed the middle of the window by 1.65 meters. So what's that, almost a couple yards? Yeah, so that's not even going to hit the top of the window probably. We're up here somewhere. That's not doing us any good to put out this fire. What is the magnitude and angle of the velocity of the water when it strikes the house? What we need to do is find the x and y components of the water when it hits the house. So we know that the x velocity stays constant. The y velocity, we're going to take the initial velocity in the y direction, then take into effect gravitational acceleration, and we find that the water is doing, in the y direction, negative 2.04 meters per second, so it's on the way down. It's already peaked. So let's see, the water's kind of like this, and it's hitting over there. So to find the total velocity, we use Pythagoras. It's 6.39 meters per second. And then we find the angle, and this verifies what we said right over here. It's hitting the building at a negative 18.6 degrees. So what's happening, it's hitting somewhat like this, and there's the 18.6 degrees. What must be the minimum angle and speed of the flow in order to get water into the middle of the window? The angle we're looking for is where the peak of the water's trajectory is right at the middle of the window. So what we're looking for is right like this. It peaks right here in the middle of the window. If we have a greater angle, like this, the water will hit too high, and if we have a lesser angle peaking, it'll hit too low. So what we're going to do is set Vy equal to 0 and use the third kinematics equation to solve for the initial velocity that we need to have this case happen right here. So our final velocity is going to be 0. Our initial is what we're solving for, and then we've got 2 times the acceleration due to gravity, and then our delta y will be our final position, which is 6, minus the initial position of the hose, which you can't see there. There it is, 1.8 meters. Put the numbers in, and we need a velocity of 9.12 meters per second to meet that criteria. The next thing we're going to do is find the time for the water to reach the window using the first kinematics equation. And let's see, over here, we're still working in y. We have our initial velocity in the y direction from the previous slide, 9.12. Here's gravity again, and it turns out the water is going to take 0.931 seconds to get there. So we've got v0y. To find the total velocity, what are we missing? Well, v0x. We know the water is going to be in the air 0.931 seconds. We will use the second kinematics equation in x, and here's 8. This is how far it is to get to the house in the x direction. We're saying that our initial x position is 0. Here's v0x, which is what we're trying to find. Here's the time it takes to hit. And our x velocity, the initial x velocity, will be 8.59 meters per second. And now we just have to put together our 2 components of the initial velocity in the x direction and in the y direction, and we find that our v0 is 12.5 meters per second. We find the angle using inverse tan, and we have to fire the water at 46.7 degrees, and then it'll go right up. Should have peaked right over there, right in the middle of the window.